So the goal here is to take our code and turn it into something else the CPU understands. That meant figuring out how to assign memory, generate the right load level code, and track everything cleanly from the compiler's side. I'm building the language, the compiler, the instruction set, and eventually an emulator from scratch. Today, we're getting the compiler to handle byte assignments and simple math like addition and subtraction.
Let's start with memory. I want byte A equals 5 to translate into two instructions. The first instruction is load immediate, represented as LDI, which loads a value into a register. The second instruction is store register, represented as STR, which moves a value from a register into a RAM address. First, we want to load a 5 into a register. We can do that with LEI 5 0, which should load a 5 into register 0. Variables are stored in RAM most of the time, and we are not using this variable yet, so we should move it to RAM to free some registers. We do that with str, a bit binary form of 0, 0. This will move the value from register 0 to RAM address 0. Now, let's say we want to assign a variable to another. For example, byte A equals B. Our code could look something like this. We can translate the first two lines as we did before, except when the user does not define a value, we will default that to 0. Now to assign A to B, we will move the values back from RAM addresses to the registers. We can use a new instruction called load register, represented as LDR. We will load A into the register, then store A into the same address as B. And that's it. We have stored a value from one variable to the other. Addition and subtraction are not much more complex than that. We can start by initializing our variables. Then we load the variables we want to use into the registers. A to register 0, B to register 1, and we don't need to load C since we are setting it. Now to handle addition. We're going to use a new instruction called ALU, not to be confused with the actual arithmetic unit inside the CPU. This is just what I'm calling the instruction in my custom set. It takes 4 things: a destination register, RC, 2 input registers, RA and RB, and an operation like add or subtract. We could make many main instructions, but this way makes the instruction set much more compact and organized. Now we can translate C equals A plus B into ALU 2 0 1 add, which would add register 1 into register 0 and put that into register 2. All we have left to do is to store register 2 back into variable C's RAM address. Good. Looks like it's working. Now for completeness, let's do subtraction as well. And also a semi-complex one. Now to LiveMe. Hello, it's LiveMe, and this is my compiler so far. So, what we could do is do the byte assignment, like I said. So, let's get 2 variables in. I do not know why it does that. Ignore the coloring for now. Then, we could do byte C. It still works without the coloring, so don't mind that. Byte A and then compile. And this is where I've been getting my code for all that editing I just finished. Just 5 seconds ago. And you could do much complex things, sorta. It's not really following PEMDAS yet. If you want another episode, I can do that, but I need an emulator. So, that'll be it. Thank you for watching, and goodbye.